So if you recall, the tide is actually a shallow water wave. Shallow water because the length of the wave is half the circumference of the earth. Therefore, no water depth is going to be greater than 1/2 that wavelength. So the tide moves at the speed of the ocean basin that it's running across. The crest of the wave is the high tide, and the trough of the wave is the low tide. So recall that according to the equation of gravity, we have a force due to gravity. This is a gravitational constant. One of our masses will be the Earth. The other of our masses will be whatever satellite we're referring to. In this case, either the moon or the sun. And the radius is the distance between those two beings. According to the math here, the masses are times 2, but the distance between them is squared. So that's going to have a larger effect. Also, it is a squared value, and it's in the bottom of the fraction. And so anything on opposite sides of the fraction, they're going to have an inverse relationship. And so the radius has a much greater impact than the size. Thus, the moon, being so much closer, is the stronger influence on our tides. So the tide is actually looking at our water is not attached to the planet, and so even though the opposite satellite, either the sun or the moon, is pulling us, trying to get us to pull towards them, and of course we're pulling back, each of us, the moon and our Earth, we're spinning on our axes. And so that opposite force that leads to the tidal producing force is due to our own centripetal or centrifugal, depending on your frame of reference, which term you're going to use. And there is a video called Chapter 10 or the Oceanography chapter that will have a link to how is the tide producing force handled. Your book also covers that. But as you can see, the total difference of the tide is the pull due to the near side of the planet and the pull due to the far side of the planet. And that causes the water to bulge on equal and opposite sides of the planet. And in that case, once we do all the math, which is above the pay grade of this course, we're looking at a cube relationship. And so the closeness really does have the larger impact. So we put all that mathematics together and we get our spinning force, which is all directions is going away from us, right here. And then the pull due to gravity, which is a directional force based on where the entity is. Ultimately, we get the little dark blue and we get our two bulges. Now, when we look at the tidal cycle based on the basin, if there were no planets, there were no land masses, we would have one giant simplistic tide, but we don't have that. And so due to the land continental interference, we get certain kinds of tides or tidal patterns. You can either get your semi-diurnal, so you find two exact locations on the map. Let's do midnight to midnight. And in that I see 1, 2 crests and 1, 2 troughs, so that is twice a day, semi-diurnal. This one right here, I'm going to go midnight to midnight, and I see 2 highs and 2 lows. However, they're unequal, so that's a mixed. And then lastly, between midnight and midnight, I have 1 high tide and, of course, 1 low tide, and that would be diurnal, meaning daily. I do want to point out here that, recall that the lunar day is actually 24 hours and 50 minutes. So you can see that here by looking at just a little bit past midnight is when we're actually right back in the same part of the either the crest or the trough. And of course that is because while we're spinning on our axis in 24 hours, the moon has moved on in its revolution around us, and so we need to go another 50 minutes to catch up exactly where we were for this whole tidal lunar configuration. It's also why every night the moon rises another 50 minutes later than it did the night before. Okay, so let's look at the moon phases real quick. A little memory trick for as you look up at the night sky, if the light is on the right, or perhaps depending on the time of the night that you look at it, maybe from the bottomish side, light on the right means it's getting bright. The moon is growing, which means we're moving from the new moon over to the full moon. So that's all the waxing side. And on the dying light on the left is not much left. Waning meaning to die. Again, depending on when you see the moon rise, it could be that it's actually on the top part that is colored. So that's a pretty good indication. Those are the 8 phases of the moon. Let's take a look at the spring tides and the neap tides. So one of them actually combines when the moon and the sun are lined up, and this image splits them into the 2 separate positions, full moon versus new moon. In either case, the sun and the moon are all lined up with the earth, and we call that situation syzygy, alignment. And during that time, the effect of the solar bulge and the lunar bulge are constructive interference. And so you get your highest highs and your lowest lows, or your highest tidal range. Down here, when they're at 90 degrees to each other, we call that quadrature. And quadrature, of course, would happen on first quarter and last quarter, where the moon actually looks like it's a half-lit moon. And during that time, the solar and lunar bulges are in destructive interference. So you get your lowest tidal range. So your highs are not as high and your lows are not as low. So what's a king tide? This is a picture of Miami. It's a section called Brickell, and they had a king tide, otherwise known as a perigee. So perigee is where during the motion of the moon around the earth, there are times when it's closer than others, and closeness is called perigee, and when it's far away, that's called apogee. So apogee, A in front of that, of course, means not. So we want to look, though, at perigee, where couple that being closer to the earth, and in syzygy, now you have an even larger high tide. And so those don't happen all that frequently, but when they do, you get situations like this flooding. Okay, so what's the tide doing on your birthday? That's the question that I would like for you to look at for this project. And so these are the images for my birthday, which is February 24th, 1965. And unfortunately, this first link right here, the astronomical data at the United States Naval Observatory, that one, it's a hit and miss whether you can actually access it. They're going through some updates, and a lot of times when you go to it, the proxy server won't let you get to it. So I'm leaving that in here because by the April 2020, it will be a good resource, and I actually love that one. But in the meantime, we can go to this time and date website. So let's go there. Let me put you on hold for a moment while I go bring that up. Okay, so here's the time and date website, and it's actually one of my favorites. I can always check the time wherever I am in the world, and it, of course, gives you the world clock and so forth. So what we want to look at is a little bit further down here. Scroll down to sunrise and sunset. So one of the questions that I've asked you to do is to find out what time did the sun rise on the day that you were born. So when you click on that, in this space you can put your location, and I was born in Huntsville, Alabama. So when I look at Huntsville, Alabama, the other thing I can do is come down to the year I was born. So 1965, and the month was February, and go. So according to this, the sun rose, this is all today's information, you have to come down to the month. So on my birthday here on February 24th, the sun rose at 6:21 in the morning. So you can go right here and see this is my birthday right here. But what's very interesting is that if you, in fact, switch over to, my mouse wants to move slow. Click on the 24th. You'll actually see the entire crossing of the moon, the sun, when it arises. So we can watch it as we go along, and boom, right there at 6:21 is when the sun rose. Okay, so I scrolled back up to the top, and now I'm still at Huntsville, Alabama, as you can see, and I want to go to the moonrise and the moonset. Actually, I want to go to moon phases. So when we go to moon phases, of course, it gives me today's moon phase, but I want to change that for the year 1965. And the moon has been doing what it's been doing, so has the sun, long before we came along. So the fact that we can predict all this is pretty cool. It's a very predictable value. So in the year 1965, I find my month, and February 22nd is my birthday. 24th, so the 22nd is the closest. So it looks like we were in third quarter, which when you leave third quarter, that would actually be a neap tide situation. And March 3rd is the full moon. So I want to come up here. So if you don't like to look at it from this area where you can see it here, then you can actually come down here. And as you see, for my birthday, February 22nd right here, is as close to 24 as you're going to get. Okay, so let me pause if I can and take us back. All right, so it's not letting me. Get back to the PowerPoint slide. So what I want to do now is look at what was the tide doing. So I'm going to click on Tidal Predictions. When you go to Tidal Predictions, I've had you go to the original place where you can pick your state by the map or by its location along the coast. And so I was born near Alabama. And just to see my choices, I'm going to click on the map right here. When you do that, you come up here and say Alabama, A-L-A, if I can spell it right, USA. So I'm not really sure which of these stations I want to go to. So I'm going to zoom in right down here and see that I have several choices to pick from. Where's the Alabama line? So I want to try to get as close to the shore as I can. So I'm going to bring up this station right here. Alabama Point. Now this is what it's doing today, and I want to go to more data. So I'm going up to more data and I'm going to click Tide Predictions. And this is what the tide is again doing today. And so when I can tell right here whether this station is something that has a diurnal or a semi-diurnal or a mixed tide. So what I'm going to do is I'm going to look for 2 exact times in the record. And by looking at the 2 exact times in the record, I can see that at 12 p.m. I was at low tide. 12 p.m. on November 19th, it was low tide. And when I find the next low trough at 11:20 at midnight, you can see that at 11:20 the next time I'm not exactly at the same point. And that's because the tidal day is 24 hours and 50 minutes. Again, as we spend in our 24 hours, the moon has continued to orbit us, and so it takes another 50 minutes. But even still, from noon on November 19th to noon on November 20th, I only see 1 full crest, and of course the 2 half troughs make 1 low tide. So it's a diurnal tidal situation. What I want to know is what was it doing on my birthday? So I'm going to come here and say from February. First I want to zoom in on just like 2 days before my birthday. So I'm going to say the 23rd, and of course 1965. To February, I'm just going to go the day after, 25th, 1965. All right, I'm going to hit plot daily. So on the day that I was born, you can see that I had a pretty regular tidal signal, and even as you pull back from here, it's like, is that clearly not mixed? All the highs are about the same and all the lows are about the same. And so again, you hone in, and I was born on February 24th at 4 o'clock in the morning. So according to this, it was almost low tide when I was born. And since we're going from a high to a low, that would be considered an ebb tide. The tide is leaving or ebbing. Now, what is it as far as a spring tide and a neap tide? So in order to do that, you pull back and get about halfway through the month on either side of your birthday. So I'm going to put my birthday right in the middle of the 30 days. As you can see, you can only do 31 days at most. So my birthday is February 24th. I'm going to go from February 15th to March 15th. And when I hit plot daily, you can see the signature of the spring tide and the neap tide. We're looking at February 24th in 1965, and although the other picture showed us that we were at a third quarter, which would be our neap tide situation on the 22nd, we're actually coming out of the tidal signal on the 22nd according to this map. And so looking at where I was born, it's apparently in a spring tide. So kind of interested to see that there's a difference between those two. Makes me wonder about this whole idea of the tidal delay and where we are. But according to the data, this is what we have. And so let's go back to the PowerPoint. And so you can see the two pieces of data that I brought to you. So your turn. When were you born? Where were you born? What was the sunrise? What was the moon phase? When did it actually rise that day? Answer all these questions and then reply to 2 other people, and let's have a good time.